All right, welcome back. So here we are. Last time we talked about multiplication when we were dealing with exponents, and as you can see, lesson 2 in chapter 7 is division with properties and exponents and monomials, okay? When we multiplied, we would keep the base and add the exponents. So kind of, common sense would tell you that when we divide, we keep the base and subtract the exponents, which you could take that for what it's worth, but it is cool, this diagram, how it kind of maps it out. If it's 2 to the 7th, that's 7 2's on top, and 2 to the 4th is 4 2's on the bottom. And if you were to use your elementary math that you've been doing for years and cancel out those 2's, these 2, these 2, these 2, these 2, you would find out you'd have 3 left over. So 2 to the 3rd, which really is just 7 minus 4. So that's how that works. And again, just like multiplying, you would do each variable separately. You're kind of going to do the same thing. And then when we multiplied, we would multiply the coefficients. So when we divide coefficients. All right, so here's example 1. Let me zoom in on that for you. All right, so we have the x's, the y's, and the z's. Now remember, when there's nothing listed, that's an exponent of 1 right there. So for the x's, 6 take away 4 is 2, so x to the 2nd. Y, 2 take away 1 is 1. Now I don't have to put a 1 there. If you did, it would be fine, but you definitely do not have to. And then z to the 3rd and z to the 1st, 3 minus 1 is z squared, and that's your answer. When they make it a little step harder, one step harder, they give coefficients, like in this example, like the 14 and the 7, we have to divide them. Or even just reduce them. Sometimes you can't divide. Sometimes the larger number might be on the denominator, and you may have to just reduce. So I could use that approach here. That gives me a 2 in the numerator. And we follow the same thing. 7 minus 5 for k would be 2. So we got 2k to the 2nd. 10 minus 3 is 7. So m to the 7th. And then these p's actually are both 1's, which means they completely cancel out, and there is no p in my answer. And so 2k to the 2nd, m to the 2nd. All right. So what about fractions and monomials? It is the same thing. So if we have separate ones, you just do each one separately. 3 to the 3rd, 4 to the 3rd, you multiply it out, and there you have it. All right, you can look through that on your own. Let's flip it over and let's go back here. Take a look at this example. What if I am squaring it, right? So remember, when you square fractions, you square the top and you square the bottom. But remember, we raised powers to powers yesterday, or in the last lesson, so you have to, kind of using the word illegally here, distribute. Take that -2 to the -3 coefficient. You have to take the 2 to the m and 2 to the n. So if I do that, I'd get -3 squared, I'd get m to the 4th and n to the 2nd. Then I do that to the denominator as well, where there's only a p, so it's p squared. We need to simplify that coefficient. -3 squared gives you a +9, m to the 4th, n to the 2nd, all over p squared, and that's it. Okay, take a look at the example in here. It is a quotient. You got a fraction bar in there. Just remember that you're going to, this is a exponent of 1, and this has an exponent of 1. So don't forget, the 4 has to be cubed as well. So we got 4 cubed, x to the 3 times 3 is 9. On the bottom, we've got 5 cubed, because 1 times 3 is 3, and y to the 12th. And then when we have numbers raised to powers, you need to simplify that out. So 4 to the 3rd power is going to be 64, x to the 9th, and 125, y to the 12th. And if it doesn't reduce before you take it to the power, it's not going to reduce after you do. So there you have it. All right. Now, sometimes we get goofy things, and you may or may not have talked about or dealt with negative exponents before. Before negative exponents, 0. Anything to the 0 power is 1. You know, case in point right here, 3 to the 5th, 3 to the 5th, 5 minus 5 is 0. Okay, so 3 to the 0. Well, look at this. If I cancel, what happens when you cancel in a fraction? You get 1. 3 to the 0 power is 1. Anything to the 0 power is 1. So pretty simple. Check out these examples. All this hoopla doesn't matter because this outside exponent is 0. Our answer is 1. That's it. Okay, in this one over here, we need to simplify them. Remember, this has an exponent of 1, so 2 minus 1 is 1, b to the first. The c is gone because it's a 0 anyway, and then d, 5 minus 2 is 3. And there's your answer. All right, now, negative exponents. So 0 exponents really easy. Anything to the 0 is already 1. Okay, negative exponents. You may or may not have been shown this before. Hopefully you have, but as a quick review, remember that when we have a negative exponent, take a look at this example. 2 minus 5 gives you a negative 3. But you can't write an exponent with a negative, you can't write a monomial with a negative exponent. That's not considered simplified. So when you get a negative exponent, it actually ends up in the denominator as a positive exponent. Take a look at this in the long version if they wrote out c times c on the top and then c times c times c times c times c on the bottom, and we cancel. When we cancel, what happens is we have leftovers, but where are they left over? In the denominator. So it is 1 over c to the third. So if you have a negative exponent, you simply place it in the denominator of your fraction to make it positive. Now, occasionally they play some tricks on you. They might give you a negative exponent in the denominator. How do you make it positive? We'll do the opposite. Pull it out of the denominator. Okay, so why am I saying this? Well, because sometimes you end up with negative exponents. Take a look at this. If I am simplifying this, now there's no other w's, so w to the third remains w to the third. Take a look at the y to the negative 8. It's in the numerator, so how do we make it positive? By placing it in the denominator. Once I do that, no negative sign anymore. And now this other one, x to the negative 2, is negative, but it's in the denominator, so pull it out to make it positive, and you get x to the second in the numerator. All right, take a look at this one. Now, because we do have some variables that are the same on top and bottom, let's just reduce it first and use our division skills, the subtraction, and then at the end we will fix the negative exponents. So first of all, reduce the 2 and the 12. That would be a 1 and a 6. So we have a negative 1 over 6. I'm just going to make that a fraction, negative 1/6. 3 minus a negative 4. Remember, that's 3 minus a negative 4, because we subtract when we divide, but when we subtract a negative, that's really plus. So it's c to the 7th. And then d is negative 2 minus 6. So that's d, negative 2 minus 6 is negative 8. So d to the negative 8. How do I write that so we don't have a negative exponent? I'm just going to leave that c to the 7th in the numerator. I'm going to leave my negative sign out front, 6 in the denominator, and d to the 8th down in the denominator, so it's positive. Now I know it looks weak. We have another example, but if you look a little closer, it's the exact same problem. All right, on the back of this second page is, because I'm so very nice to you, even though we have a book assignment, it is the numbers from the book. Right here, remember we're doing this on a separate sheet of paper. It's 19 through 41 odd, and then 45, 47, 49. All right, please copy them down. And I know we've got fraction bar. You probably need to do that fraction bar on 2 lines like so. So number 19, you know, if you're writing that, m to the 4th p squared over m squared p. You probably want to keep it like that. I know some of you are capable of writing it like that, but let's just be safe. And so we've got 4 minus 2 is m to the second, and that's a 1. So 2 minus 1 is p to the first. Okay, so there are your answers. There's your problems. Good luck. I'll see you tomorrow, hopefully.